So today I want to walk you through one of the problems I had while developing Bushcraft Survival recently that genuinely stumped me for at least a day. And I think it's an interesting problem for me, anyways, because I've been programming for a long time. So oftentimes I know about problems. I might have a problem, but I know what domain it's in and I know what to search for in order to solve it. This problem was interesting in the sense that I really didn't know where to start when I first noticed the issue. And in fact, when I designed this particular mechanic, we're going to look at the lean-to structure building mechanic in the game. When I first encountered it, I didn't even know that it was going to be a bug. So I designed the whole system, developed it, implemented it, and then only through testing did I actually discover that something was broken. So I'm going to show you in the game here. We're going to build a lean-to structure, and the basic idea is that you have to find a tree. You're going to pick a point somewhere up the tree's height, and then the different prompts are going to tell you, not wide enough, or I should connect this to another tree. And then finally, when you connect it to another tree, you get the little green dialog. And then that's basically the first step of a lean-to system. The cross log, as I'm calling it, gets placed across the tree. And then we get another prompt here where the cross post meets the first tree. We kind of lay down another log, right? And then we have to do this one more time. So prompt says where the cross post meets the second tree. Okay, so we do that. And at this point in the design, I really wanted this nice green highlighted box to kind of help the user continue to build. So for instance, the next steps of building, we lay down a couple of these cross posts or lean posts. I think we need 4 in this case. And so the first real reason I guess I wanted that green box is the next step of the building is you have to place boughs all over the surface of this, right? I didn't really want them to be placed on these guys, these logs. I wanted them to be placed on the surface that was actually going to make up the back surface of this lean-to structure. And yes, it is a little bit video gamey. It's not perfect, but from a design standpoint, it actually works out really well. And you can work through the percentages and figure out exactly how to, calculate the coverage. In this game, of course, the coverage is really important. So I'm actually going to block out a couple lines of code here, and we're going to rerun it, but we're going to do it slightly differently. So basically, I took out what eventually became the fix for this problem. Let's find our 2 trees. I don't remember which 2 they were. Instead of doing left to right, I'm actually going to change the order. I'm going to pick the right tree first. And the game really has no idea what tree you pick first. It really isn't going to know. That's totally player's choice. There's no way to control that. But when we pick the second tree, now it says where the crosspost meets the first tree, so you have to place it here, right? And we're going to do the same thing on the other side. All right, so pop this in, and then all of a sudden we see the bug. I saw this the first time, and I just was genuinely confused. I thought something in the rendering was breaking, or I didn't know genuinely at first. But if you pop your head around to the other side, what you'll notice is that all the back faces are rendering in this case, right? So this really messes up the collisions, of course. It messes up the rendering. The rendering is not too hard to fix. You could turn off backface culling, but that doesn't really solve the issue, especially with these translucent materials. They don't show up the same. I'm actually using a bit of a Fresnel effect to create this kind of green gradient. So rendering both faces wouldn't work very well. And then the other thing is you can, in a raycast, hit back faces, but it just wasn't working. Like I tested that. I tried, turning off culling, having the raycast hit both faces, and it just wasn't working. So really, I needed to figure out how the heck am I going to get this little system to identify when the user does things in an order that I didn't anticipate, and then I have to flip the winding order basically on all the triangles. Not only the triangles for rendering, but the triangles for the collision as well. The way this script kind of interacts with the rest of the code is we have this function called load 6 points. It's it's really not very fancy, and the external calling code is going to load 6 points in, and those points are P0 would be like the first tree location, P2 is the other tree location, P4 and P5 are the origins of those trees, and then P1 and P3 are the locations that you target on the ground in order to place those lean logs. So once you have all of these positions loaded in, it was pretty simple, I guess, task at that point of just drawing the triangles. And my initial thought was, I can just directly specify the index order. So we can go say 0, 2, 1. So 0, 2, 1 is going to create a triangle like this, right? 1, 2, 3 is going to create a triangle like this. And then 401, we keep going here, right? So 401, this one's also clockwise. So we generate a triangle like this, right? And that front face is going to be this way. And then finally, we have the last one, which is 325. And this one tripped me up a little bit. We need to wind this from this perspective counterclockwise because the face is actually going to be facing out this way. All right, so that all works. There was no problem with that. And putting that in code was really simple. I'm using Godot's surface tool. We create a new primitive triangles. Then we specifying the UVs was just basically picking a corner on each one of those surfaces and make sure they map to somewhere unique on the UV map. The rest was kind of just fudging around these numbers. But then here are those indices that I showed you in my very nice Microsoft Paint drawing. So at this point, ignore all this code for a second. I had no idea how to solve this, right? I really didn't know. And then eventually I was poking around, and I finally remembered. I teach robotics at college, and we talk about the right hand rule all the time, doing the cross product and figuring out if you use the right hand rule, are you going to be able to figure out the normal direction, right? So I was staring at this and thinking about that problem, and I didn't even realize that basically this problem has already been solved. But usually it's deeper in the engine, right? So this is a problem that rendering engines definitely know about, physics engines know about, in order to figure out, is a mesh, like the question you're asking is a mesh convex, right? So if we flip these and have all the faces pointing out, or is it concave, right? Where the faces are kind of pointing inward. And in fact, concave might even be something like this. It's not fully closed. So I guess the interesting thing is at the time I didn't know it, but what got me onto the solution was thinking back to, I guess, my domain experience from robotics, where you use the right hand rule. And the right hand rule, and in fact, the way we teach it is a little bit different, where we teach the pointer is X, the middle finger is Y, and then the thumb is Z, which actually would align to how Blender does it. So this is kind of what got me onto it. And I was thinking, well, I need to create a vector, like, let's say this is the X, right? And if I make this the Y vector, then I should be able to orient a cross product between these two that basically allows me to figure out, is the face pointing out? So that's kind of where I started. And at this point, I realized I could do this for all of the triangles on this mesh, and figure out, is the normal based on the existing winding order, do the normals point out or do they point in? But really, that was only half the problem. So once I kind of clued into the fact that I need to figure out whether or not this object has the normals pointing out or pointing in, there was kind of one key thing I was missing. And that was basically this: you need to know where the centroid of the mesh is first. This was kind of the last thing that really solved it. And of course, the centroid is pretty easy to calculate. You just grab an array of vertices of the whole mesh, you add them to a sum, and then you divide them by the total number of vertices. So in this case, the centroid would kind of be somewhere maybe about here. And then what you need to do in order to verify a particular triangle, right? I have this handy dandy function here called calc normal that does exactly what that picture just showed. You take, say, P1 minus P0. So in this case, let's literally look at P1, P0, 1, and 2. If we do P1 minus P0, that gives us a vector that points like this. So that goes from 0 to 1. If I have a vector P2 minus P0, that is going to be 0 pointed to in the direction of 2. So I can also do this as a cross product. And in this case, if my x is pointing this way, my y is pointing this way, I expect the z, or the z-axis, to be pointing up. It's based on how the cross product works. So I know I have this, but that doesn't really tell me much, right? Like, what am I comparing this to? And once you get that triangle normal, we really need to check the centroid of the triangle to the centroid of the mesh. And this is really kind of where the whole thing comes together. If you take this particular triangle here, right? Let me use blue so it actually matches. The triangle itself has a centroid, like somewhere like maybe here, and that's the center of that triangle. And what we want to do is take the direction of the centroid, the triangle centroid minus the centroid of the mesh. So that would be a new vector that points like this. Okay. I think I might be doing it backwards. The centroid minus the centroid of the mesh means you go this way. And the question is basically, does the orange vector and the purple vector, are they at least, somewhat pointing in the same direction? So to kind of look at it in a 2D plane, are they kind of looking like this, for instance? And if they are, that tells you that this face is correct. The normal of this face correctly points out in the way we expect it to based on where the centroid of the mesh is. Right. So that's basically it. And of course, to do that, the thing we all know that what tells you the similarity between two vectors, the dot product. So we get the dot product between that direction of the center of the mesh to the center of the triangle, and then we calculate the same similarity. And the triangle basically is not verified if that value is less than 0. If this value is negative, if we, for instance, get an orange triangle that, let's say, my line tool, let's say the purple is going this way for any particular one of those faces, and then the other one, I probably should get a better tool besides Microsoft Paint for this. But let's say the other one is facing totally in the opposite direction. Well, cosine of greater than 90 degrees is going to be a negative number, right? So this value trends negative, and then we know that all of a sudden the normal of the face does not align with the direction of the center of the mesh to the center of the triangle. And what we can do is we can iterate over all the triangles, right? So iterate over all the triangles, and then we just call this verify try function. If the verify try function fails, I have this flip value that I increment. So this is a little bit ad hoc. I mean, doesn't have much to do with the actual solution. But if we find any triangles that fail that, then we flip the winding orders. So actually all we're doing here, and I made it even simpler actually, is the indices we're keeping the same. But what we're doing is we're changing the order, the winding order of the points as we brought them in. Because originally it would have been P0, P1, P2, P3, P4, P5, right? That was the original order. And the way that works, the reason I'm switching them in this way, I'm actually switching 2, 3, and 0, 1, right? So if you look at 0 and 1, that would be, let's use a different color. That would be this guy and this guy. So I'm actually swapping these two sides, right? So the sides from the right come over to the left. So 0, 1 become 2 and 3. And then we have, what else? So 0, 1 become 2, 3, and then 5 and 4 swap, right? So 5 and 4 swap. So these two, this one just comes over here. And that's it. So once I swap the left and right sides of this triangle, that solves it. So I'll show you quickly in the engine. So now the code is uncommented, right? So if that flip value occurs, then it will actually flip it over. So let's do it in the wrong order, right? We're going to go to the right tree first, then the left tree, then put that first post down, and the second post down. And so voila, now our mesh as well as our physics, our mesh as well as our collider are flipped. So that's kind of it. That's kind of the problem. I can tell you firsthand that this was extremely gratifying to solve. I don't encounter problems that stump me this hard usually. Especially like when you've been programming a really long time, you kind of you know what you're in for, you know what to Google, you know what to search, right? You know where to go on Stack Overflow or forums, whatever it is you do. But this one was unique. This one really stumped me for a little bit. And I tried a bunch of different things and I was saying, "Oh my God, do I have to redesign this? Do I have to go back to the drawing board and figure out a new way to do this?" But no, I kind of persevered through that. I found a solution by doing this whole calculation about where figuring out is the mesh actually convex or concave, which is a pretty generalized problem. I'm sure there's more sophisticated solutions you would need if as that mesh gets really complicated, but for this specific case, it works really well. Anyways, I just thought I would do this quick devlog for other developers might find that interesting. And yeah, you should tell me about what problems you encountered, what kind of crazy things you come up with and you see in your game dev journey. So, anyways, thank you for watching. I will see you next time, and please let me know down below what you think.